Welcome back. So we started the talk on arrays in the first two videos of this first unit in unit 1. And now as the third video, I just want to go through arrays with you guys. Much later, we're going to write programs with arrays. Think of arrays as lists that we had in Python. Same thing. Array, list, same WhatsApp group. So just that here, it's much more sophisticated. And it's not just like a variable, it's really an object, and we're going to talk about that much later. I just want to show you a few examples so that you know what to expect. In C#, you have access to arrays that are two-dimensional, all right? And you have an arrays that you call arrays of arrays, or alias jagged arrays, all right? So a two-dimensional array is like a table, all right? And when you're declaring them, you say something like this. Int, instead of just a variable, you say int, then you put square brackets with a comma to say there are two dimensions here, and you give it any name you want before the semicolon. Again, we're going to look at examples. And if you really want, you don't want it to be a box, you want it to be number of rows and number of columns are different. You can declare an array that looks like this and specify 110 rows and 100 columns. All right, it's always row, comma, column. All right. And you must remember that the array is also zero indexed. Remember our range in Python, when we say range 5 and we have to start to 0 to 4, something similar to that. So when an array is declared as 10, it starts from 0 to 9. Of course, we look at examples later. And jagged arrays are arrays of arrays. So it's like lists of lists in Python, which we looked at. Excuse me. And in this case, when you're creating a jagged array, you first declare the jagged array. However, for each of the position of the array, you can then specify how long those positions would be. So if the array position 1, like here, position 0, that's the first position of the array, you can still put another array in there that has 10 spaces. And for array position 1, you can put another array in there that has 20 spaces. So you end up having an array with different length of columns. All right, so basically that's the idea. But we're going to see examples. This thing, sometimes you need a picture in your mind to understand how it works. Sometimes it's easy when you kind of draw it. So let me see if I can pop up paint and kind of sketch something for you guys quickly. So this is paint. I'm drawing with a mouse, so it's not going to be pretty. So think of it this way: 3, 4. So 1, 2, 3, 4, 5, 6. So if I have a jagged array that has 3 rows, row 0, row 1, and row 2, the first row can have 6 items, and I can have another second row that is just 2 items. So, and I can have a third row that is even more items. Maybe, again, I don't want to be drawing all of those lines. I can say this is 10. So these arrays are jagged inside this one, all right? So which gives us rows and columns. Unlike the other two-dimensional array, that number of rows and number of columns has to be the same. It's like a brick. You can use this kind of arrays for different problems too. All right, so we're going to look at examples at some point. So framework class library. So it's called FCL. In the .NET framework, there are class libraries which are like some magic boxes where there are some predefined commands you can use to write your code. One thing I can cite that you can remember clearly that can make you understand this is, remember when we were dealing with Python, we had predefined functions like math, square root, sine, cosine, all of those things. So here we have the same thing. And however, all of these things are wrapped inside different classes. We call them the framework class libraries. So I can say using, let me see, system dot, okay, let me just look for something in system dot data. So these are all libraries. So this is the whole idea of framework class library. All right, dot text dot regular expressions. So those are libraries. There are stuff in the text.cryptography, okay. There are stuff in security, for example, security here, dot cryptography, as you can see, There's permission policies. Cryptography, for example, is the theory of information security, encryption and decryption. So the whole idea is that all of these things are libraries all packed together in all of these namespaces. And that's why we say that .NET Framework has framework class library namespaces. So these are namespaces, system namespace. Another example of a namespace is Microsoft namespace. Microsoft dot, like you can see, you can access Visual Studio here, you can access C# language, SQL Server, and you can get a server object. You can, so all of those things are framework class library. So it's not something off. And the whole idea is it's nice when you read about it and get a clear picture so that you can understand what we're doing here. A namespace is not an assembly. So an assembly, sometimes you have more than one namespace in an assembly. And sometimes a namespace can be spread across different assemblies. So again, it's nice to know what that means. It's in your reading. And summary of these two major things. You have common type systems. You know what that means. I've explained it. You have common language specification. You know what that means. And again, namespace help us to organize, like you've seen in the case of system namespace, helps us to organize the libraries that are usable in C# and generally speaking in .NET Framework. And assemblies also help us to implement what you call packing, meaning that finally, if I need to use it on my project, it's shipped to me in a DLL, Dynamic Link Library. I'm going to show you guys on future time. And that's a package. It's like a file, a real file. You can copy it, move it around your computer anywhere you want. So, exercise, design a simple adder program in C# to take two integer numbers and return the sum. So we're going to do these exercises so we can start getting used to it. Two integer numbers. I'm going to say int. You can call them A and B. Let me just say number 1 and number 2. Number 1 and number 2. Again, remember, since an integer number, int is out to declare any variable name you want, and then we're done. So I need to read these numbers. I will just copy some of the code I have here that I can use instead of typing everything all over again. So I'll put this here, and this is number 1 is equal to that. Okay, that works fine. Then I will just copy this and paste it for number 2. So at the end of this lines of code, I must have read number 1 and number 2. So the next thing is to add it together. So I can, in C# you can actually define and use a variable on the same line. So let's see that. I'll say int sum equals, then I'll say number 1 plus number 2. All right, that's fine. End of line character, never forget that. In my experience, most C# programmers for the first time, novice programmers we like to call you guys, always forget the semicolon and you'll be busy debugging. Oh, where is my bug? That's always one of the things you should always look at first. So now that we have the sum, I can display the solution with the console or right line. You see, I'm just copying some things here. So I can say sum, okay? And my program is done. So I'll just put my console.read key here. And the rest of this code, so that it doesn't confuse you, I'm just going to remove it. So it looks clean. So there you have it. Two variables, number 1, number 2, read the variables and add it together and display the sum. Let's go. So I'm going to run this code fragment. Let's see. Coming up. Again, we don't have prompts in our programs yet, so it's looking like a dark screen. 4, if I put 7, then I'll get 11. It's working fine. I may want my program to be a little bit more interactive. So what do I do in that case? I may want to give a prompt before, which is like we did in Python. Please enter first number. All right. And that's going to appear on the screen. The user knows what to enter. Then I'm going to just copy this line and paste it here. And I'm going to call this one second number. And then number 2, then when the result is coming up, I'll do the same thing. I'll just say answer equals, again, I could concatenate. However, I want you to remember that this sum right now is an integer, and this part is a string literal, And in order to avoid some complications, it would be nice to convert this sum to a string. So when you convert this string to string, everything is fine. If I don't do that, the conversion happens anyway. It's called implicit conversion, meaning the compiler handles it. However, that's not like a good practice. A good practice is when I say dot to string. So there's something called dot to string. It's a method that I can use to just convert a variable straight to string. All right, and that looks perfect. Looks elegant. Let's try it. So I'm going to save that, run, and my stuff is coming up in 0, 1. There you go. Enter the first number. Let's say we go for big numbers now, 15. Enter the second number. If we go 35, we should get 15. 35. Answer equals 50. Works perfectly well. So that is the simple exercise there. I want you to extend it to multiplication. So have fun and practice. So I'm going to give you some of the programs you have in Python before. Please begin to explore to convert it to C#, even if we've not covered the code the control structure in that language yet, but you can have some fun. The next unit, we're going to talk about control structures. I'm going to look at similar algorithms you've seen. However, this week, I'm going to give you guys very simple programs that involve addition, subtractions, no loops yet, no if statements yet, so that you can then practice how to convert these things. See you guys tomorrow for the questions and answer for the week by 12 noon. And you get the practice, you also get your reading. Have a good one, guys. Boom.